Okay, thanks, folks. We have a good number of people here already. It's on the button, 11 o'clock EST, so I'll get us started. So my name's Dr. Pat Kiley. I'm CEO of Sentry. Really happy to have people here. This is really exciting. I'm going to introduce our two presenters today very shortly. The focus of the presentation today is going to be on the pulp and paper industry. So really, for me at least, the key takeaways that I want people to get from this, generally speaking, I just want people to learn something about the wastewater. Wastewater as it relates to the pulp and paper industry, either the problem statements and some of the solutions and some of the people that are working in this space. For me, the pulp and paper industry and the wastewater aspect of it is amazingly interesting. And the problem statements that people in that industry work with are quite acute, actually. So we're really happy to be part of that. So for today, Manaz, if you could go to the next slide there quickly and just bring up yourself and David. So for today, the two presenters, we have David Spencer. So David Spencer is the project coordinator for EBS. So EBS provides a blend of technical consultancy and services to their industrial clients. They do have a big focus on the pulp and paper space, and they work with the 4 largest pulp and paper companies in North America. Manaz Zar is with Sentry. Manaz has a background in civil engineering, master's in civil engineering and water from University of Toronto. And Manaz is our senior client manager and a data analyst for Sentry. So with that, Manaz, I'll hand it over to you, and you can get us going.
Thank you, Pat. Hello, everyone. I hope you are well and safe during these pandemic conditions all over the world. So the agenda for today, I will introduce the Sentry technology. I will go over through the problem statements in pulp and paper industry and the importance of real-time monitoring of biological activity in wastewater. The first case study will be presented by David Spencer. And then the second case study I will present the economic impacts and then the questions. So Sentry is a electrochemical system which power is applied to the system. It has anode and cathode parts. And they are measuring MET, which is the real-time carbon consumption data. The MET data is sent to a live dashboard, and the client has access to the live dashboard. So the redox reactions, oxidation and the reduction are happening at the anode and cathode, and they are producing MET data. In this webinar, we are focusing on the problems associated with the pulp and paper industry. In general, in pulp and paper, wood is used as a raw material to produce pulp paper and paperboard and other cellulose-based products. But there are 3 general categories of problems that need to be addressed, including sustainable forestry practices, resource use, emissions to water, air, and land. In this webinar, we are focusing on the emissions to water and the wastewater treatment industry in pulp and paper. Pulp and paper receives water from a variety of sources in the mill. The processes include pulping, which is producing methanol, power and recovery, which is producing black liquor and turpentine. Another step is bleaching, which is producing caustics, acids, and color bodies. And paper machine process, which is producing fiber and the starches. All of these processes contribute different contaminants to the system. These are usually measured as BOD, this contaminant COD, TSS, high and low pH, toxic events including black liquor discharge, and foaming events. So it is very important to control the wastewater and the contaminants that are going to the environment. However, pulp and paper mills are running 24/7 throughout the whole year, so it's virtually impossible to find out when the issues are happening in the process and if these issues are having adverse impact on the treatment system. In order to run a successful and a steady biological process, it is important to monitor the 8 growth pressures, including food, such as BOD, pH, temperature, dissolved oxygen, nutrients such as nitrogen and phosphorus, retention time, toxicity, and the health of biomass. So, however, the known and unknown events may cause variation of the characteristics of wastewater, and these changes can add additional costs up to $200,000 to the treatment system. Some of the additional costs include supplemental nutrients, bioaugmentation, or adding other products to help avoid potential BOD breakthrough to the effluent stream and violating permit discharges. However, currently there are limited tools available to monitor the biological activity within the wastewater treatment system. Sentry is one of these tools that is helping to monitor biological activity in real time in wastewater treatment. And in this webinar, we are presenting 2 case studies that have used Sentry. The first one is a bench scale liquor detection, which EBS used Sentry to monitor detection of black liquor discharge in their lab settlement. So David, it's to you.
Okay, great. Thanks, Minaz. Appreciate y'all having us on to go over what we looked at in a warehouse setting. As Pat mentioned, my name is David Spencer, and I'm the project coordinator with EBS. Just a little background. We are a wastewater consulting company that provides a variety of services and products to basically any refinery, paper mill, chemical processing, food processing plant that has wastewater systems. Roughly 80% or so of our business is from the pulp and paper industry. So we've seen a variety of different impacts and situations where spills and upset conditions in the treatment systems can have a profound effect on what happens. So just a little bit about black liquor. For those of you that do not know, the pulp and paper industry utilizes a procedure known as a craft process, where wood is converted into wood pulp and then into paper. In the process, some of the wood is dissolved, and together with the spent pulping chemicals forms a liquid called black liquor. The liquor is separated from the pulp by washing, then sent to a recovery boiler where the inorganic pulping chemicals are recovered for reuse, and the organics are used as fuel to make steam and power. However, some of the recovery processes don't always work as planned, and accidentally liquor can end up entering the treatment system, which can, we all know, have some profound effects on the health of the biology and the overall treatment capacity. Some of the components of the black liquor consist of wood lignins, tannins, resin acids, fatty acids, excess sodium, sulfur, and a variety of other toxic compounds. It's highly caustic and is characterized by high inorganic and organic loads. And because of that, and the reasons listed here, the spills can often put a period of upset conditions and potentially push the BOD beyond your aeration capacity in the system, leading to permit violations. So for our bench scale analysis, our overall goal was to quantify the impact of the black liquor spill on the microbial electron transfer and to see how it affected that based on, you know, what we were normally getting, and also to validate Sentry as a real-time solution to detect these extreme loading swings, such as black liquor spills or any other spills that may occur. So to achieve this, this is kind of our setup we had in the warehouse. It was two tanks filled with 25 gallons of pulp and paper wastewater. They were fed a flow of approximately 12 gallons per day. So we're roughly at a 2-day retention time under aeration. We ran this setup for approximately a month or so before starting the trial. And each day we consistently ran total insoluble COD and BOD and compared it to the METs to kind of get a baseline of what normal was. So once we established that portion of the analysis, we added weak black liquor from the same paper mill that we would get the wastewater from, just to see how it would compare to the control tank. So we fed black liquor to tank A, and the control remained the same, normal loading, normal flow as it had. And as you can see right here on this graphic, tank A is the orange, and tank orange and black. So we ran CODs, and almost initially, as soon as we spiked the tank with black liquor, you saw a sharp increase in both the CODs and the METs, which indicated it responded well to the increased loading from the black liquor. It remained elevated for a few days and then slowly declined. And in comparison to tank the control, which nothing was done to, everything remained relatively consistent. This next graph is the dashboard view, and you can see where the dosing event was. Line in blue is the tank that was fed with the black liquor. And as mentioned earlier, you know, you saw a pretty immediate spike, indicating that there was some higher loading of coming through, whereas the control remained relatively stable. And then after a few days, the spiked tank eventually came back down, whether it's through retention time or the black liquor was degraded, but back within the stable readings.
Okay, thank you, David. So the second case study, this is Sentry was to monitor real-time biological activity in the lagoon, and if Sentry can be used as a real-time detection to help operators detect biological upsets at the lagoons. Base mill is located in North America. The picture is showing the aerial view of the wastewater treatment. There are cell C1 and C2, and ZT are the water is flowing from C1 to J1 and then C2 and then ZT, which is acting as a smaller finishing cell. There are 3 spill basins, spill basin A, B, and C, which are acting as holding ponds. The star here is showing the location of Sentry installation. C1 and C2 are in series. The water which is coming to the lagoons is not cooled and typically enters at around 50 Celsius degrees. Only one Sentry system is installed at C1. It has a retention time of 4 to 5 days. And as mentioned earlier, the problem statement was to see if Sentry can be used to effectively monitor the health of the treatment lagoons and provide more rapid notification to operators about developing issues. The client provided us with two parameters, TATP and biological stress index. TATP is the total adenosine triphosphate, which is the health of the biomass concentration. We benchmarked TATP data to MET data from June to August. There are 5 periods on this graph, which I'm going over each of them to explain them. The first period, which is highlighted in yellow, is showing extended inoculation time, which was unique due to the high temperature and nutrients dynamic. So during this period of time, MET is increasing. There is increase in growth biomass, while MET is getting inoculated to the new condition. The second period is showing some disruptions and changes in sensory response, followed by TATP changes, and which are indicator of changes in BSI, which I will go over that in the next slide. The rise in TATP is consistent with the rise in MET, but it's unstable. Both MET and TATP are unstable during this period of time, and which is leading toward a decrease in biomass afterwards. This period here is showing a shutdown period. The TATP was lower. MET was also considerably lower during this period of time, followed by an increase in TATP and MET. However, there is a shock to the system on July the 30th, and a smaller one here around August 5th, which is followed by a crash in biomass due to treatment shutdown. And we see that MET is kind of lower during this period of time. So MET tracks quite well with TATP, and it is more, it is reactive to stressors quicker than TATP testing, because the client is doing a massive sampling. They are doing 4 TATP and 5 COD samplings per day, which is expensive. And for the TATP testing, the operator or someone at the plant has to actually physically go grab the samples and analyze them. The next slide is showing the same period of time MET response with the biological stress index, which is equal to dissolved ATP, DATP divided by TATP. The DATP is the measurement of concentration of ATP from dead cells, which is measured as dissolved against the total. So the higher the DATP, the higher is the stress index. There are 4 periods on this graph which are marked. The first one, there is a shock to the system on July the 2nd, which is followed by increased BSI or a stress index. Then July 18, there is a significant increase in BSI, which is also showed by a significant decrease in MET response. Then we are seeing that MET and BSI are going back to normal conditions. But there is again another shock on July 30th and August 5th, which is leading the reduction in biological activity, and is further confirmed by the reduction in TATP concentration. So this case study is showing that MET has correlated well with BSI and TATP, so it can be used to for a real-time monitoring of the biological activity and help operators of real-time conditions. Another slide, this is showing the real-time data from the dashboard for the same client. Sometimes in the pulp and paper, the pulp mill effluents foam because the wood chips are not fully recovered in either the tall oil or the recovery system, which is resulting in foaming conditions. Sometimes the treatment system needs to control the foam. This client is not using any defoamer in the lagoons. When the situation returns to normal, the foam decreases. But I overlaid in this graph 2 weeks of data from the red line is showing 1 week without foaming event, and the blue line is showing a week with foaming event. This highlighted period is showing the days where client informed us that the foaming event has happened. So the biological activity was lower compared to normal, and it had more noises. But then after the foaming event was resolved, it went back to the normal conditions. And since we had alerts enabled on the dashboard, client was able to receive the notification that something is happening in the lagoons. So to compare the economic impacts of conventional water quality sampling to Sentry cost benefits, I did a simple comparison between both. I used the data from BV Labs to calculate how much it costs to do BOD, COD, and TATP sampling. So it could cost more than $10,000 per month to do the conventional sampling. It has a high cost, and we are only getting single data points. We are not able to see and analyze real-time conditions. For remote plants, sampling can be limited, and not always the data is of good quality. However, with Sentry, real-time monitoring of conditions is available. It has higher resolution. It is producing 1 data per minute, so it will be 1,440 data points per day. It is suitable for remote plants. There are opportunities for plant optimization, such as we have a couple of clients that they have used Sentry to improve their aeration. The cost of sampling can be reduced up to 80%, and the online dashboard can be used, and clients are able to see the data online, and notification can be sent to them by email. And more importantly, it costs lower compared to conventional data analysis. It only costs $1,000 per month compared to more than $10,000 for conventional sampling. So to conclude this webinar, we have the data and the case studies show that Sentry is validated for real-time monitoring of biological activity. It is responsive to biological upsets. It has a lower cost compared to conventional analysis, and it has low maintenance. And thank you, everyone. If you have any questions.
Fantastic, Manaz. Thanks very much. So I'll maybe just try and quarterback the questions and the next steps. I will summarize briefly for people just to remind people of what we've gone through. So generally speaking, the summary is the pulp and paper industry has, massive issues in having to deal with wastewater. The wastewater generated at these pulp and paper sites, let's be honest, it's not what you'd consider nice wastewater. It's cellulosic type compounds that are really hard to break down biologically anyway. And then you couple that with all of the toxicity that's inherent in that wastewater stream. So the operators of these facilities really have to be on the ball. They really have to understand what's going on in there in their lagoons or their treatment systems. So having your finger on the pulse, having a real view on the biological activity is central. The work that we did with EBS, the first work we did with EBS, was all around helping them, understand, can we identify these black liquor spills? It's those spills of black liquor that really cause significant issues. So if we can, help them and help the operators understand that, when those events are happening in real time, that can be a real, a real positive spin, or a real positive step for the operations of those facilities. So that's it. So with that, if there's questions, if people want to put a few questions in the chat section, we can direct questions back to David and Manaz. Anything about the pulp and paper industry, about the wastewater, the type of wastewater, the Sentry platform itself, how it works, what it uses. We're happy to take those questions at this stage.
And just to get started there, I believe there was a question in there about how does MET different from measuring ORP, oxidation reduction potential? Yeah, thanks for that question. Basically, microbial electron transfer, MET, we're actually reading what is the current organic consumption rate of a representative biofilm in the system. How fast are they currently consuming organics? So it's similar to an ORP measurement in that you are assessing the environmental conditions, the changes in selection pressure, changes in organic concentrations and availability of electron acceptors. But essentially, we'll actually, ORP is giving you that chemical reading. What is the pressure there? What are the, what is the available pathways? And for MET, we're saying what are the biology actually acting on? What conditions are actually taking place? So the difference being that you can have, different types of inhibitory compounds present that might not, or you can have types of organics which might not be readily be degradable by biology, giving you a different signal for your ORP. So I'd say that the MET signal is a bit more biologically relevant. And then on top of that, we're not using any sort of reference electrode or anything that doesn't want to be in wastewater or fouls quickly in wastewater. We're actually using, a catalyst which is based on microbiology, which are, already present in that wastewater.
Fantastic. So Jack, I'm just going to follow up there with one for you on the back end from Daniel as well. So it's like BOD versus COD. Do you want to just comment briefly again, just clarify for people? There's ORP, there's BOD5, and then there's understanding MET or microbial activity. Do you want to just briefly touch base on the three of those again?
Yeah. So so it's like BOD versus COD. Yeah, it's similar in that you would be yes, taking the fractionation of your ORP that is most relevant to the biology. We're actually doing, we are microbial electron transfer. We're just the kinetics rate. So BOD is measured with, uninoculated biofilm. So yes, what we're actually just saying is this is the real-time consumption of organics at that location. And as this goes ups and down, this can be tracking with either, the pressures in that wastewater. If it's just varying, organic concentrations, that would be those shifts in those organics as well, yes.
Fantastic. Okay, so we have one other question there. One is specific to Lake Baikal in Russia in terms of what the effluent quality, how that would impact lake water quality. I don't know what the effluent standards are for Russia. Someone might have to educate me on that one, but I would hope and assume that there is some level of treatment taking place before that wastewater is being discharged into the lake. Derwin is asking, what is the general cost of installation of this entry analysis? And does it vary according to the treatment system? So what I will do, generally speaking, and for installations in the US, you can work directly with EBS and contact David. For installations in Canada, you can reach out directly to ourselves or Manaz. Generally speaking, we provide a standardized package, and the general cost breakdown, it's about $10,000 per annum. And with that, you get all of the sensors, the online dashboard, the control, so all of the equipment, and it generally works out being around $10,000 per annum for that service. So we typically provide a monitoring service.
And just to clarify, Patrick, we do work outside of North America as well, and that would be directly to Island Water Technologies, so Manaz or Patrick on that. So,
thanks, Jack. One question there from a Tom Williams. How difficult is this to install? I'll answer that one, I think. It's quite straightforward. So the sensors themselves just look and feel like pH probes. So you do need to have, you know, access to your wastewater, but the sensors can just simply be lowered into the wastewater. There's no pumps, there's no moving parts. The sensors are just, you know, like DO or pH probes, very simple, very standard, and you just place them in the wastewater. So once the sensor surface is submerged in the wastewater, that's all you need, and there's no real complexity other than that. So we just want the biomass to grow on the surface of the sensor and become a representative surface in that wastewater environment. Thank you. Okay, so we have a few more. Does the probe output an analog signal and can it be incorporated into an existing PLC? Yes, so we're providing an output. Colin has responded there, but generally speaking, when we work with our clients, we provide a control panel with, you know, 2 to 4 sensors, but we will take that data and send it to a cloud so that we can, you know, monitor the performance of the biology remotely as well with the customer, so we can all both see what's going on. But you can also simply take a 4 to 20 milliamp output on site and connect that to your on-site SCADA. So you can view it both on the cloud, or you can just view it whatever way you would normally be viewing the data as well. Okay, perfect. And that seems to be it for questions. What I will say to people is we'll follow up. So we'll send everyone a copy of the presentation afterwards. If anyone has any questions about the pulp and paper industry, about the problem statements in the pulp and paper industry, if you're interested in Sentry, if you have any toxicity in your wastewater treatment process, or if you're worried about process imbalance, if it's the pulp and paper industry in the US, feel free to reach out directly to David Spencer. His contact details are on the slide. Anything else related to wastewater, whether it's Canada, whether it's internationally in Europe, then yes, feel free to reach out. Manaz's email contact information is there. So feel free to reach out and send us a note. I think that's it, folks. Thanks very much. This is very efficient, a 30-minute webinar. I love it. I hope everyone learned something. And if anyone has any other questions or follow-ups, yeah, feel free to reach out. Thanks very much, folks.
Thank you.